Dear friend, I am here with the part 2 of the lecture 1 of module 3. In lecture 1 of module 3, I have drawn the shear force and bending moment diagram for a continuous beam AB and BC, which is subjected with this loading pattern, 40 kilonewton point load at a distance of 1 meter from support A. There is a continuous loading, you can say, uniformly distributed load of 20 kilonewton per meter to a span BC, and there is a point load at the tip of this overhang 10 kilonewton. And I have calculated shear force and bending moment diagram. We have done this part in lecture 1 of part 1. You can see my lecture 1 module 3 lecture 1 part 1. You can see SFD and BMD, Here at the end of the part 1 of lecture 1 of module 3, I have told you that I will be solving for a bending moment diagram for the same continuous beam, but at that time it will not be a through loading diagram, it will be from using conventional method. Here I am continuing this part 2 for developing bending moment diagram using conventional method, which is based on the principle of superposition. Here you will see after step-by-step calculation how we are able to develop a bending moment diagram through conventional method. First I want to show you the preview of lecture 1. This is the preview of the lecture 1. Here we we calculated the SFD and bending moment diagram for this load, and for this beam we have converted to an identical beam of this by removing the overhang part, by converting this point load with a moment of 20 kN in clockwise directions. Then I have formed a distribution moment this is the distribution factor table, and found our distribution factor. You can go for the detail how we have calculated this one. Then this is the moment distribution chart, how the moment is distributed I have explained in detail, and we have taken the final support moment, which is calculated at the last. This is total, you can say, final moment at the support at every joint. And after that I have calculated the SFD. I have formed the SFD shear force diagram. For that, this continuous beam, I have shown all the moment which is calculated from the moment distribution chart. This is the external loading. These are the external loading, and I have calculated shear force diagram by separating this AB and BC in two separate beam. It is two separate beam, and I found out reactions R1, R2, R3, and R4. I have calculated for a span AB. I have taken reactions R1 and R2. Then I have taken R3 and R4 for a span BC, and I have summarized the all reactions R1, R2, R3, R2 and R3 is here. There is R1 and R4. These are the reactive forces, and through the reactive forces I have drawn SFD. Now I have continued the same lecture for forming the bending moment diagram. For that I have used this loading diagram. This is the final loading diagram, having all the reactive forces, all the calculated moment at the support, and all the external loading which is applied at the beam two span, in this two span. Now we have used two separate beam AB and BC separately, and taken the reactions and applied load and the calculated moment, and calculated the moment at D in order to form the bending moment diagram. And for span BC we have calculated the span moment at the center of this beam, you can say mid span span moment. And I have taken reactive force R3 and R4 here, in using the can say conservation of moment. We have calculated the moment at point E and found this value, and at last I have drawn the BMD bending moment diagram. All these for calculating a bending moment, for in drawing, in order to draw a bending moment diagram, we have applied a loading diagram. Through this I have used the all the reactive forces and all the calculated moment at support and all the span moment calculated after separating two different beams by, you can say, by splitting in two different forms, A, B and BC, and we found out moment at mid span. This is the maximum moment, here is the mid span moment, and I have explained you how we have developed this bending moment diagram. But this time I am not going to follow this pattern of calculating or forming a bending moment diagram. I am going through a different method that is called conventional method, and which is sometimes used if you are going to find directly the bending moment diagram without finding support reactions, or you can say without finding reactive forces. If somebody asks you to form shear force and bending moment diagram, then it is very easy to form the bending moment diagram through the loading diagram, because first, if you are going to develop a shear force diagram, you need to find the reactive forces. Then after having the all reactive forces applied, you have the applied loads and calculated bending moment through the bending moment charts, you can develop a bending moment diagram. But in the conventional method, you can find the bending moment diagram without having reactive forces, just having the loading diagram of bending, having the loading diagram of calculated moment at supports and the applied load. You can develop a bending moment diagram using conventional method with the help of principle of superpositions. Now we just moving forward to draw a bending moment diagram for the same beam which is subjected with the load, as I explained you. Now here is the beam. You can see this is the beam. This is the beam. This support is A, this support is B, this support is C. Here 40 kilonewton of load, applied load, is acting at a distance of 1 meter from support A, and this support is fixed support. This is the, and there is a UDL of 20 kilonewton per meter is acting here, and there is a overhang length of 2 meter from support C, having a point load of 10 kilonewton at its tip. This is the actual problem, and after drawing after a moment distribution chart, we have found the bending moment diagram. You can see now I am going to draw the loading diagram. This is the applied load only, it is shown in the problem, and I am going to draw a loading diagram of this by removing the support, fixed support, where using simply supported, you can say, pin support here. Now this is the applied load which I want to show you. This is the applied load. This is the problem statement. You can say this is the problem statement. Now we are going to draw the loading diagram, and here loading of 20 kilonewton per meter of UDL is, and as per our moment distribution chart, You can see here is a joint support A, this is support B, and this is support C. And now here we have calculated the final moment. This is the final moment. So at A we are having a final moment of minus 10.39. It means it's simple moment in anticlockwise direction, as we have assumed anticlockwise moment is negative. I have explained you in part 1 of the same lecture. So here is the anticlockwise moment of 10.39 of moment is acting here in kilonewton meter, and then you can see there is a moment of 23.67 which is positive. It means it is in clockwise, 23.67 kilonewton meter, and there is anti-clockwise moment of same, because it's a negative, it's with negative sign, so it will be anti-clockwise direction. So 23.67 kilonewton moment is acting here, and support C is having a clockwise moment of 20 kilonewton moment. This is our loading diagram. And now we are going to develop bending moment diagram for this continuous beam, but without reactive forces, using all these loads. These are the external loads. This is external load, this is external load, and this is the calculated moment at joint. Calculated moment is the final moment through the distribution table, because moment are distributed through the joint firstly, then after calculating the loading diagram we can also find the span moments, then after we can draw the bending moment diagram. So we are going to draw bending moment diagram, BMD is what. Now let's move. Here is, we have developed the loading diagram through the bending moment chart. Now I am redraw the same loading chart here so that it will be easy for you to understand. This is joint A, this is joint B, and this is joint C. A, B, and C. This is the this is the load of 40 kilonewton at a length of 1 meter. This beam is of length 3 meter. This beam is length of 4 meter. There is a anti-clockwise 10.39, and here moment, calculated moment as per the bending moment chart, 23.67, and here is moment of 20, and there is a UDL of 20 kilonewton per meter. Now in order to draw the bending moment diagram, we are separating AB and BC for our easy calculations. So separating first span AB. Here is span AB. Span AB is loaded with 40 kilonewton at a distance of 1 meter, and this point is A, this point is B, and it is also and support moment, you can say support moment is 10.39. here support moment at B is 23.67. okay, now we are going to draw the support moment diagram. Support moment diagram will be developed here. We are taking the same span AB, and support moment value at B is, this is the point A, this is the point B. Here support moment value will be 23.67, and here support moment value will be 10.39, and adding this one we will find a support moment diagram. This is the support moment diagram. This is what we call it, support moment diagram. Support moment diagram. A support moment we are using with hogging moment, so it's with negative sign. Now we are going to develop a span moment for the simply supported beam. Now span moment will be, we are drawing the same beam here. This is A, this is B, and as you know, this simply supported beam is supported with a point load of 40 kilonewton. This beam is here with 40 kilonewton of load at a length of 1 meter. This length is 3 meter. So as we know, for a simply supported beam having a point load, its moment is WAB divided by L. Here A will be equal to 1, this is 1, and B this is the B, this is 2, L equal to 3, total length. Now as per, and this is W, so moment will be 40 multiplying with, in place of A will use 1 and 2, in place of B divided by 3. 40 into 2, you can calculate here, 40 into 2 divided by 3, it will be 26.67 kilonewton meter. This is the maximum moment at this point. So this is the point A, this is point B. At a distance of 1 meter, we will take a point, the value will be 26.67, and we will just develop a bending moment. You know a bending moment diagram pattern for a point load. This is the span moment for the simply supported beam AB, and this value will be coming with a positive sign because it is a sagging moment. Now this is the support moment, this is the span moment. This is span moment and not the final span moment for this beam, because this is a simply supported span moment, and this is the continuous beam. So the final span moment will be from the superposition of this and this. Suppose this is the figure 1, you can say this is figure 1, this is figure 2. Now final bending moment diagram for span AB will be final bending moment diagram of span AB will be the superposition of figure 1 and 2. Superposition of figure 1 plus figure 1 and figure 2. Now we are going to superimpose this figure 1 and figure 2, then you can see how we are going to develop the bending moment diagram for this span AB. Now we are dealing with the span AB. So this is the beam, this beam is AB, this point is A, this point is B. Now as we have developed, this is the bending moment diagram. This value is 10.39, and this value is the support moment 23.67, and span moment at a length of 1 meter from the support A, its value is 26 here, 26.67 as I have calculated here. I have just explained you 26.67, this value and this value I have written here. And now connecting this one and connecting this one, we have developed a bending moment diagram, but still it's not final value. The common value of this one will be the hashed portion. This will be the final bending moment diagram for span AB and span BC. No, sorry, span AB only. This span AB, the hashed portion. Now this is the maximum span moment, but it's not the span moment of this this is AB. So we need to find the value here. We need to find this value. You can see here is the value, and we need to find this value. This value will be the span moment for this beam AB. Now our main aim is to find this value. Suppose, let's say we are going to designate this value that I have marked here is y1. Then we know this is the maximum value at this point, which is at a distance of 1 meter, and suppose this is m is 26.67, and if we are able to find this value, suppose this value is y2, if we are able to find the value of y2, then m minus y2 will give the span moment of this beam AB. That will be the final span moment, because the span moment of this beam will not be this value. This is the simply supported maximum moment of value 26.67. So let's clear it. Now y1 value we need to find, that is our subject of analysis, and y2, if we are able to find y2, then y1 will be m minus y2. Now we can see this is the trapezoidal shape. You can see this is the trapezoidal shape, and with this trapezoidal shape we can find the value, because the this support moment is ranging from 10.39 to 23.67. Now separating out this support moment, we can find out easily y2 through you can say similar triangle method. You will see here. Now I am drawing this trapezoidal shape having the support moment. This is the value. This value is 23.67. This value is 10.39. Now this point is A, this point is B. This is the support moment, and if we are drawing a line parallel to AB, this is here, so here 10.39, so here value will also be 10.39. so we can find this value. This value will be 23.67 minus 10.39. This value will be 23.67 minus 10.39. This is the value, that is 13.28. Now at a distance of 1 meter, here at a distance of 1 meter from here, we need to find a value. This is value of y2. We need to find out this value value for y2. Now we know this value. This is 10.39, and suppose if we are able to find this value, let's suppose this is y3. You can say this value is y3 here. Then that will be, this value is 10.39 plus y3 will be the y2. Y2 will be 10.39 plus y3. y3 is this one. Here you can see this is the y3. Now you can see here from the similar triangle we can separating out these two triangle here. There is one triangle will be this one, there will be one triangle its total length will be how much? 3 meter. This value I have calculated 23.67 minus 10.39, this value is 13.28. And there will be another triangle, this triangle, that there will be another triangle. This is the one, another triangle will be here at a distance of 1 meter, length will be 1 meter. This value is y3. We need to find out this value y3. From similar triangle we can calculate this value of y3. Now we can do as from similar triangle 13.28 divided by 3 equal to y3 divided by 1. This is equal to y3 will be 13.28 divided by 3. The value of y3 will be here. This is the y3, the distance of 1 meter. 13.28 divided by 3, it will be 4.43. The value calculated here is 4.43. Now we are done with the calculation of y3. We know this value is 10.39. So y2 will be from this expression 10.39 plus y3 value 4.43. This value will be 10.39 plus 4.43. It will be 14.82 kilonewton meter, as we are dealing with the moment value. 14.82 is the value of y3. Now for the, as per the expression of this, y1 value will be, this is the y1. So therefore y1 will be m minus y2. M value is this one, this is the total value, this is the 26 point, M value is this one, this is the 26.67. So in place of M we will put 26.67, and in place of Y we will put 14.82. So value calculated here will be 26.67 minus 14.82, it will be 11.85 kilonewton meter. So this is the span moment at for span AB. The final span moment is the final span moment for span AB. Final span moment for span AB. Now we are going to find the final span moment for span BC. So so that compiling AB and BC we can draw the final bending moment diagram. As you can see, here is our loading diagram, and we have analyzed with span AB, and now we will analyze with span BC. You can see here span BC is this is a simply supported beam, and span is this is the B and this is C, and it is loaded with loaded with bending moment of No, this is a UDL of 20 kilonewton per meter. UDL of 20 kilonewton per meter, and it is also having a support moment of 23 in anti-clockwise, 23.67 anti-clockwise, and a clockwise moment of 20 at support C. This is the loading diagram for span BC. Now for span BC, we are dealing with span BC. Now this is simply supported beam. We have the fixed moment. Final support moment is 20 for support C and 23.67 for support B. Now we need to find the final bending moment, that will be the span moment for span BC. As we know, simply supported moment for a beam which is subjected with UDL. This is a simply supported beam. This is the B, and which is loaded with a UDL of value 20 kilonewton per meter, and length is 4 meter. You can say L equal to 4. And this is W, L equal to 4. The maximum span moment for this beam is the AB. Maximum span moment will be WL square divided by 8, and in place of W you can write 20 L. In place of L it will be 4 square divided by 8, so its value will be 20 into 4 square divided by 8, it will be 40 kilonewton meter. So simply supported span moment will be here. Simply supported is, this is the beam AB, this is beam AB, and as you know, for as you have analyzed a determinate beam, and for a simply supported beam which profile is a parabolic in nature, so its bending moment will be of this shape, and maximum bending moment as I have calculated here is 40 kilonewton, and as per our assumptions, sagging moment is positive, so this is the bending moment for span AB. So we can say this is simply supported span moment, not the final span moment. Simply supported span moment. Now for span BC, we can see this is the support moment of 23.67 at support B and 20 kilonewton meter at support C. So we can draw a support moment of span BC at point B. This is the point B, this is point C. We can draw span support moment from this value. It will be 23.67, and here it will be 20, and it will be connected like this one. This value will be 20, and as per our assumption, support moment will be of hogging nature, so it will be with negative sign. This is the support moment. Now as per our analysis, as per our analysis of span AB, we are going to develop the same thing here. We are going to superimpose this figure and this figure to find out the final span moment as well as support moment, and that will be the final bending moment diagram for span BC. So this is the figure, you can say 3, and this is the figure 4. So final bending moment diagram will be final bending moment diagram of BC will be superimposing figure 3 and figure 4. Here we are going to superimpose figure 3 and figure 4 here. Now I am going to redraw figure 1, figure 3. Figure 3 is here. This is the support moment. Value is here. This value is 20. This value is 23.67. This is of fogging nature. This point is B. And this is the figure 3. And we are adding this with figure 4. This is the figure 4. Maximum value is, that is called M, equal to 40 of with positive sign. This is the same beam BC, and figure will be 4. This is the span moment of the simply supported beam BC, and this is the support moment for simply supported beam BC. And by superimposing figure 3 and figure 4, we can draw it here to be something like this. This is the 23.67. This is 20. Drawing here, and span moment will be something like this. This value will be 40. They made a span. This is the final moment. So here you can see the final bending moment diagram will be this kind. Will be the hatch portion will be the final bending moment diagram. This hatch portion will denote the support moment. This hatch portion will denote the support moment at C. At this point B, it will be the support moment, and at this point, at this span from here to here that I am drawing, this will be the span moment. So calculated value of 40 will not be the final span moment. Final span moment value will be, that will be the maximum value. It will be here from here. This will be the final maximum support moment. Oh, sorry, span moment. And same, suppose this is y1 and this final value, this is the simply supported moment, which is M. Value is 40. If we are able to draw, if we are able to calculate the value, this value, same we have done for span AB. This is y2. If we are able to calculate this y2, then y1 will be M minus y2. And we can calculate y2 very easily, as the support moment profile is a trapezoidal shape. So from similar triangle we can calculate the value of y2 here. Now we are taking support moment profile here. This is the support moment profile. You can see here. This is 20. This is 23.67. This value is 20. At mid span, we need to find this value. This value is y2. If we draw a parallel line, suppose this is the point A, this point is B. If we are drawing a parallel line, this which is parallel to AB, and this value will also of 20, so we can calculate this value here. This value will be 23.67 minus 20, it will be 3.67. 3.67. This value will be from this to this 23.67. 3.67. Now this value is 20. If we are able to calculate this value, you can say here, if we are able to calculate this value here, then y2 will be, suppose this is y3, this value is y3, therefore y2 will be 20 plus y3. Okay, now calculation of y3 is very easy. We will take this triangle for our analysis, this triangle, and there will be another triangle, two triangle. Now we are separating this triangle here. The main triangle will be this value we have calculated here, 3.67. Length of this triangle is, base of this triangle is this length is 4 meter, so it will be 4, and this will be from A to B, and we are taking another triangle from here to here, this only. There will be another triangle. This point will be C. Suppose we are dealing with these points, the mid span is E, so this length will be 2 meter. That is, as we are going to calculate the span moment at center of this beam, mid span moment, and we want to calculate this value. This is the y3. This is y3 here. From similar triangle, this and this, we can calculate y3. Here we can do here this 3.67. This 3.67 divided by 4, this is length 4, will be equal to y3 divided by 2. So it will be, y3 will be 2 to cancel here, with 3.67 divided by 2, which will be equal to 3.67 divided by 2, it will be 1.84 kilonewton meter. This is the value for y3 calculated here. Now y2 will be 20 plus y3 as per this equation. Y2 will be 20 plus y3 calculated is 1.84, therefore its value will be 21.84 kilonewton meter. Now as per this formula here, y1, this is the subject of our analysis, the final span moment. Y1 will be m minus y2. In place of m, we can put the maximum value of m is 40, that you can say 40, and in place of y2, we can, as we have calculated here, this is the value of y2, so we can write 21.84. so this value will be 40 minus 21.84, this value will be 18.16 kilonewton meter. This is the maximum final span moment for span BC. This value will be 18.16 kilonewton meter, and in figure in span AB, the maximum final moment was, we have calculated here, 11.85, and we have the support moment for span AB, and we also have support moment of span BC. By combining AB and BC, we can draw the final bending moment diagram from here. Now final bending moment diagram will be, drawing final bending moment diagram. Final BMD. here with this we are taking this span AB. Here is span AB. In a span AB, there is a support moment of 10.39 and 23.67 at support B. There will be support moment of 10.39 here. We'll just draw the value here, and there is a support moment at point B. This is the point A. The support moment value is here 23.67. Here you can see 23.67. You can see 23.67 here. 23.67, 10.39, 23.67. And now joining this one, we are just drawing only the support moment, and we are taking joint C. Here the support moment is at point B the same 23.67, but at C there is a support moment of 20, so we will draw a value of 20. It will be somehow larger than this, so it will be here something, so it will be of this value will be 20. This value is, and this at point B there is a support moment of 23.67. Now as we have calculated here at a length of 1 meter from support A, there is a span moment we have calculated here. This value is 11.85, final span moment. So at a length of 1 meter, we are taking a point 1 at a distance of 1 meter, and its value will be 11.85. It will be some slightly larger than this. We are taking with this. Oh, sorry. Now at a distance of 1 meter from support A, the maximum bending moment which is calculated is 26.67 from, as you can see here, WAB divided by L. So here the maximum moment will be of value 26.67. So here value will be somehow larger than this, so this value will be 26.67. This is the maximum moment, and it will be here to here. And in span BC, now dealing with the span BC, there is a maximum span moment of 40 kilonewton, 40 kilonewton meter, and this curve is of parabolic curve, so we'll draw a maximum moment at the center of this beam at a distance of 2 meter. Now its value will be some kind of this one, and this value will be 40, and this will be this final serrated shape will be the final bending moment diagram. This is the support moment, and as we have calculated this value, this is the span moment for span AB, this value will be 11.85, as we have detailed with you, 11.85 final span moment. This value will be 11.85, and if we can draw here this point, so this is the maximum point now. Span, this value will be 18.16. 18.16. This is the final moment at a span. This is the 18.16. Y1 we have calculated here. This value is 18.16. This is the final bending moment diagram. Final BMD, bending moment diagram through conventional method. conventional method. You can see the same calculated value which I have drawn through the loading diagram. You will find the same value of bending moment, span moment, or you can say support moment. This is the bending moment diagram which was drawn. This is the superimposition of span moment and support moment. Then after superimposing two values, we have shaded out with the final bending moment diagram. But here we can directly draw the bending moment with a loading diagram. The value calculated is here. This is the span moment 11.85. The same 11.85 we have calculated using the conventional method. And here at span BC, the maximum span moment was calculated 18.17. The same value we have calculated here 18.116. So now and the fixed end moment is same. Fixed support moment is same 23.67 here. 20 is at support B, C, and 10.39 at support A. So I have done with the calculation, or you can show I have done with the formation of bending moment diagram through conventional method, and I hope the concept regarding conventional method might have cleared to you. And if you find any difficulty in an understanding or if you find any ambiguity, you can raise your concern in the comment box. I will surely answer to you. Keep watching and keep sharing to your friends. Thanks a lot.